Okay, now we're just going to do a few extra things here. First of all, we're going to get what's called the correlation coefficient squared, and I guess we could look at this. So, since this is not a course in statistics, we're not going to cover the details of this, but this function takes two arguments usually, and you're looking for the correlation between those two arguments. Now in our case, we will also take two arguments, and we'll run it like this. So we're looking for the correlation between attendance and predicted attendance. And we hope that they are almost the same, or in fact we would hope that they are the same, that attendance and the predicted attendance were the same. That would mean that our model worked perfectly. And so anyway, we want to calculate this. So let's see what it looks like when we do it. So here's the results. So our model is not that great, actually. We would like this to be closer to 1, but this means that our model did not capture about 55%. There's 45% of we say 45% of the variation was captured by the model, but 55%, the remaining part, was not captured by the model. Okay, now we're going to take the trained model, the trained test set, the trained set, and the test set, and we're going to merge them back into this. Now, I think we also have added to these, let's check that. Yeah, up here, like here, the Dodgers test set, we added, remember, the predicted attendance. And the Dodgers train set, I think we did the same thing. Yeah, we added the predict. So now they have an extra variable in them. So we're going to put them to. Now we're going to take these two sets of data. They're both actually data frames, but they have an extra column in them. Each of them do, and we're going to combine them using row combine, which means we're just going to. This is a whole bunch of rows, and this is another set of rows, same columns but new rows, so we can combine them, just adding one set of rows to the other set of rows with this function. So we have this. Now, did I run that yet? Okay, so let's run that, and then let's see what it looks like. Basically, let's look for the new column. So I'll just do the head. And we'll just be able to see the new column, which is called predict attend. So this is the predicted attendance. Now this next one, I'd like you to help me with this next one, because I don't quite see what's so good about it. He's going to generate a plot which he says is good for management. Usually when he says it's good for management, it means it's for people that don't really understand what we've done, but they can understand the results. But let's run it, and if you have a feeling for why this is good, then let me know. This one here. Now I can explain part of the reason why this is good, but so one thing, it doesn't seem to me like management will understand this well, but maybe you can see why management will understand this well. What I will say about this is, for example, in the test set, so these are the, we had, I forget how many, something like 20-something elements in our test set of data. And so what we have on the x-axis is the actual attendance versus the predicted attendance. Now, if all of the dots were on this one line, that would mean we did perfectly. it means that this is a 45-degree line, and that would mean that the predicted and the actual were exactly the same because they're on the 45-degree line. So that would mean that our predictions were predicted exactly what the actual attendance was. So we'd be very happy then. Now, this is not all on this line, so we're not as happy. And but I'm not sure that management would really understand this picture. And the other thing that I can see here is that the bobbleheads are higher than the non-bobbleheads. So management would say, "Oh, it looks like when we have when we're doing bobbleheads, we get more attendance, right? They're up here. They're not down here somewhere where you get a low attendance, whether it's actual or predicted." Well, we're actually interested in the actual, but so down here would be low actual, and here. So this shows you that the bobbleheads do, in general, have higher attendance rates, so that they could see that. But showing the actual versus the predicted, and the point there would be that we want everything to be on the straight line. I'm not sure that management would realize that we want everything to be on the straight line. So if you have any ideas about why management would like this graph, I'd be happy to hear about it. Okay, we'll do just a little bit more in the next video, and that will be the end of the analysis of the code.